Hello, in this video we'll be going over rates of change as a function. So as we've seen in class, the derivative of a function f at x equals a is denoted by f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. And this evaluation gives the instantaneous rate of change of y equals f of x when x equals a. So as we can see here in this diagram, we have the average rate of change between a and x, but if we let x approach a this way, we will obtain the instantaneous rate of change, or the derivative. As we've seen in class, we can also use the average rate of change formula, f of x2 minus f of x1 over x2 minus x1, to get the average rate of change between any two inputs. And this will be used to approximate the derivative, f prime of a, if we let x1 and x2 be close to the value a. Here we'll consider a population of fruit flies, which the count of the fruit flies is available on a given day t. In this chart here. So first we'll start with the average growth rate of the population from day 25 to 40. So what we want to get to calculate this is to employ the average rate of change formula from t equals 25 to t equals 40. So we will have q of 40 minus q of 25 divided by 40 minus 25. And this is a measure of population divided by days. And we will evaluate this by just taking the numbers off of the chart. We'll get 340 minus 240. So a net change of 100 fruit flies in the course of these 15 days divided by 15 total days. And we will get 100 over 15 number of flies per day, or 6.6 repeating number of flies per day. In this part, we will go ahead and estimate the instantaneous rate of change of the population at t equals 40 days. And we have a little bit of freedom in how we do this, but will lead to the best answer. So we can actually choose x1 and x2 to be 35 and 40 to get a good estimate from the left. And we can go ahead and choose 40 and 45 to get a good estimate from the right. And then we'll just go ahead and average those together to get the best estimate for our instantaneous rate of change of the population at t equals 40 days. So from the left, we'll do q of 40 minus q of 35 divided by 40 minus 35, which will be, in our case, 340 minus 310 over 5, which is equal to 30 over 5, or 6. Six flies per day, same units as part A. And from the right, we'll take q of 45 minus q of 40 over 45 minus 40, which will give 360 minus 340 over 5 again, which will result in 20 over 5, or 4. So if we average these two values, we'll get about 5 flies per day. And that is our best estimate for our instantaneous rate of change at t equals 40 days.